Hello, and welcome to Introduction to Optimization. This video shows how to optimize the Rosenbrock function in Matlab using fminunc. The Rosenbrock function is a classic function that is often used as an example of unconstrained optimization. One of the most common forms is shown here, with f as a function of f and y. The Rosenbrock function is also commonly known as the banana function because of the banana shape formed by its contours. As can be seen in this graph, the Rosenbrock function forms a long, low valley. If we graph the z values on a log scale, we can see that within the valley, there's a distinct minimum at x equals 1, y equals 1. The goal of the optimization is for the optimizer to find that minimum, which has a value of 0. Let's take a look at how to do this in Matlab. Here's a script I've created to solve the Rosenbrock optimization problem, which is also available through the link in the description. Let's walk through the different pieces. First off, we'll define the Rosenbrock function. If you're using Matlab newer than the 2016 version, you can define the function at the bottom of your script. Otherwise, you'll need to put it in a separate file. One trick here is that I'm defining the function to take a single argument, which I'm going to call in for input. This will actually be an array of inputs. Once the input is passed to the function, we'll unpack it into x and y variables, and then use those in the Rosenbrock equation. This will be the objective function that our optimization is trying to minimize. Next, up top, we'll clear the workspace and set some options for the optimization. These options set the optimization to display its progress and to use a quasi-Newton optimization algorithm. Next, we'll define values for x and y. For now, we'll just leave these at 0 and 0. Notice that I'm putting the guess values into an array. This array needs to be the same size as the input array my function is expecting. Finally, we'll call the optimization algorithm. Because this problem has no constraints, I'm going to be using the fminunc function. The first input is the name of our function. The second input is our array of guess values for x and y, and we'll also pass in the options we're setting. The outputs of the optimization are the optimal values of x and y, as well as the value of the Rosenbrock function at that point. Let's go ahead and run our script. Okay, so as you can see, because of the display option we set, the optimization spits out a lot of information. We can see the progress of the objective function on every iteration, as well as how close to the optimal solution it's getting. We can see that a minimum was found, which is good. We can also see that the optimizer has decided that the best values of x and y are both 1, which is what we wanted to find. Finally, we can see that the value of the function at that point is 0, which matches up with what we know about the Rosenbrock function. So, to summarize, we defined an objective function, chose an optimization algorithm based on what we knew about the problem, decided on some guess values for our inputs, ran the optimization, and then looked at the results to see if they made sense. Thank you for watching Introduction to Optimization. I hope that you enjoyed this video. Click these links for other videos on optimization topics.